Good morning. Good morning. You're welcome to our today's lecture. We are still on the course Basic Dispensing Theory 1. BUT 152. We are still on the topic Suppositories and Pessaries. This is our seventh contact. Hence, Suppositories and Pessaries, part 7. In our last class, we discussed the water dispersible base, and we completed the hydrophilic bases. So today we'll go over to another subtopic, which is method of manufacture of suppositories, different method through which suppositories and pessaries are manufactured. Basically, we have the hand molding, we have compression molding, we have pour molding, and automatic use of automatic molding machine. So under the automatic molding machines, we have the use of rotary machines and the linear machine. So these are what we are going to look at under this subtopic. Okay, let's go over to hand molding. From the name, as the name implies, this one is manual. All you need to do is just do what? Roll the suppositories on the what? Tile, then cut to the desired shape, and they point the one of the ends to be pointed. So actually this is the oldest and the simplest method. Is oldest and what? Simplest method of what? Preparing suppository. Of course, it should be extemporaneous. Am I communicating? Because I don't know how many suppositories you can produce with hand for large scale production. All right, so the steps involved here are as follows. First of all, you get the drugs and the additive, that is the drug and other ingredients, with the exception of the what? The base, okay? So you mix the drug itself and other additives, then in powder form, okay? So when that is done, you now incorporate it inside the base by kneading, or you can even use what? You can titrate. Am I communicating? So you can titrate, so mixing them with what? The basis. So after that, of course, while doing that, you need to apply what? Lubricant on the what? On the tile. You saw tiles in your lab, right? Did you see tiles there? Okay, you've not, okay. You are still doing your O-level stuff, physics, chemistry, okay. Don't worry, maybe from your second years, you start see. So if you see tiles there, know that the tile there is not just there for fancy. That's a purpose for keeping it there. So here now you make use of the word, the tar, out together. So you apply lubricant on the what? On the tar. So that's where on the tar is where you roll the what? The mix. So you roll the mix to form what? Cylindrical what? Shape. So when that is done, you do what? You then cut it into what? Rods. Then point one end. Make one end to be what? Pointed. You know that the one end of the suppository is what? Pointed. So that's basically what happens in what? Hand molding. In hand molding. So when that, after having done that, you do what? You store and what? You package and do what? Store. Of course, we've discussed the temperature range. We've discussed different bases, their temperature. Of course, you know that if you use glycerol gelatin base, and if you use glycerol gelatin base or even macrogos, and if you use theobroma oil, you know that they're not the same thing. Hope you know. Storage. All right, let's continue. So that's what happens in what? Hand molding. Then for compression molding, this one gives suppository with elegant what? Appearance. So that means this one suppository formulated or produced using compression molding at least will have better aesthetic value than the one you do what? You mold them with your hand. Am I communicating? Of course, you should know that. Common sense should tell us that. Because the other one will be rough, true of us. But the one with compression molding will have more elegant appearance. So elegant suppository can be made using what? Compression. So and that point here is that this one doesn't require heat. Am I communicating? You're not making anything. It doesn't require what? Heat. So here now, the cold grated mass is what? Good morning. Are we together? Is compressed in what? To give the desired what? Shape. This one is simple and more elegant appearance. Is simple and has more elegant appearance than the what? Hand what? Molding. Hand what? Molding. Another advantage over hand molding is that it avoids the possibility of what? Sedimentation. Am I communicating? Remember what I said when you have insoluble what? Solid. Remember what I said. What will happen? There is tendency for them to do what? Sediment. Can you remember? There is a tendency for them to do what? Sediment, especially when it takes time to do what? Set. True of us. So, but that one is produced here. So, a very important advantage of this is that thermolabile drugs can be what? Produced using this what? Method, because heat is not what? Required. Thermolabile drugs can be formulated into suppository using this method because heat is not what? Required. And of course, when compared with with hand molding, the rate of production is what? Higher. True of us? Good. Now, what are the disadvantages? The main disadvantage of this is what? Air entrapment. Air what? Entrapped what? Meant. Air entrapped. So air can be what? Entrapped. Are we together? Air can be entrapped. That's major disadvantage. So during the production, air can be what? Entrapped. So if air is entrapped, you know the implication. Oxidation, right? Good. Oxidation can easily do what? Take place. So these are the potential issues it may have. So that during production, you know how to guard against it. Now, so basically what happens is that you mix the drugs and the additives as usual in fine powder. When this is done, you then mix with the base. Of course, you apply the mold. You should apply the lubricant in the mold. Then after that, what next? You now place the mass in the cylinder. You apply pressure. You do what? Apply pressure. You put the mass in the what cylinder and apply pressure. So when that is done, you do what? You release the what? Suppose even though you don't hit, but at least you know when pressure is applied, you know the relationship between pressure and temperature. Hope you know. Are they directly or inversely? Temperature and pressure. Do they have direct relationship or inverse relationship? Is that it, right? Good. So when that is done, you cool them, pack, and do what? Store. So the next one, please, as we move to the next stage, if you have any question, feel free to ask, please. Don't keep quiet. Not at the end, you start taking us back to. As we move to any new section, please, if you have any question, please feel free to ask. So the next one is what? Pour molding. Pour as in P. You can call it pour, P-O-U-R, or heat what? Heat what? Mold. You can call pour. To pour something now, to pour, right? And heat what? Molding. Okay, so what happens here? So this method is commonly used for production of suppository both in small and large scale. Note that point. It's commonly used for the suppository production both in small and large scale. So what happens here is that first of all, you need heat here because you need to melt, okay? Here you melt the base on water bath. You saw water bath in the lab, right? So water bath is put in use here, okay? So what do you want to achieve by using water bath? What do you want to achieve? Why must you use water? Can't you just put it in and heat it in open air? So why must you use water bath? Huh? We discussed this in your first semester. So why water bath? Since you have heat, you have Bunsen burner there, you have things you can use to melt water. Why must you put it in water bath? Huh? You forgotten? Wow. Huh? So why water bath? The idea is that you want to melt it at constant what? Temperature. Okay, you want the temperature at which this is happening to be what? Constant. You want to regulate, you want to maintain the constant what temperature. Please, that's the most. That's why you if not, you can just melt it. So you do what? You melt on water bath. Then when you do that, the drugs are then what? Depending on nature of the drug, they can be emulsified or they can be what? Suspended. You know when they are emulsified, you know what it means. That means there is issue of partitioning. True of us, water, oil are involved. Now, true of us. Then when you suspend, you know what it means. It's not what soluble, right? Good. So depending on the one you want to achieve, but the basic thing is that anywhere, whether you are dissolving, emulsifying, or suspend, whatever you do, the point is that you mix the what, the drugs, additives, and the what, and the base. Okay. So whatever you are doing, the idea is that you want to do what? Mix the whole thing together. So when you do that, what is next thing to do? You then pour the mix in what? Mold, in metal mold. You've seen the molds, right? It's not true. You've seen the molds. Okay, turn to the next page. Can you see the molds? The metal mold. Can you see them? Can you see them? Yes, these are the molds. These are the molds, okay? Can you see the two suppositories still inside the mold? By the right, can you see two suppositories? Yeah, so this is the mold, okay? So when you hear mold, this is what mold. As you can see that it has the shape of the what? Good. So you know you've melted already, right? Good, you now pour. Okay, allow you to do what? Cool. They will retract, they will contract so that they can leave the what? The wall of the wall. All this we're talking about adhering to the wall of the mold. This is what you are trying to apply lubricant to mold. Will not allow them to. It's like those that can you know there are some base that don't need lubricant. Hope you can remember. Example is what? Example is what? Doesn't, but you said to be one that doesn't require. I said the one that don't require lubricants. The one you just discussed last. Ah, okay, let's continue. So, all right. So now, what happens is that you then pour the melted. You know, everything has been mixed in the molten form. Malt. You know what molten is, right? You know what molten is, right? Molten form of a substance is the liquid form that did not dissolve or disperse, it just melted. If you have candle wax, melted candle wax, that liquid candle is in molten form, okay? If you have metal now, you can heat metal until the metal turns to liquid. That liquid is not a solution, it's not a suspension, it's in molten form. If you pour it somewhere, it will set. True of us, when temperature comes down, it will do what? Set. So that's what happens now. So that molten form, because you have heated and mixed other ingredients, you now pour in the mold. If you pour it in the mold, and they will do what? Set there. That's what the evidence is why that issues. The certain time should be very, very short, because if it takes time, what you mix inside it will do what? Sediment. They will not be dispersed. True of us, they will not be suspended. They will just do what? This, and they will sediment and pack one side. Am I communicating? Even though there's nothing much, because if you use but it's not even good to sediment anyway. All right, are we together? Now, melting of the bases. So now let's look at let's have a rundown of what I just explained now. So what happens is that first of all, you melt the base. Can you see the schematic representation? Can you see it? First of all, you do what? You melt the bases. So after melting the bases on this side, the base is there, you are melting the base. Then the drug will now be put in what? The drug and whatever you are adding, you put in what? Fine powder. After putting it in fine powder, you titrate with warm water. So when you do that, you now have a liquid, right? It can be solution or suspension, depending, right? Then when that is done, you divide it into two. Half of it you mix with the base, okay? The melted base. Then after mixing with the melted base, then before you now do what? Mix proper, then add the remaining what? Liquid. Did you understand what I said? Yes. After making it in liquid form, you do what? You have to titrate in what? Warm water. You divide it into two. You mix the first half with the what? The melted base. Mix properly. When that is done, you then do what? Add the remaining what? Liquid. Then, when this is done, you mix properly. You now apply what? Of course, you apply the lubricant in the mold, right? So when that is done, you now do what? You now pour the what? The liquid, right? You pour liquid. If you pour liquid, please, as you are pouring liquid, pour it to get filled up. Okay? Let it overfill. Do you know why? Because it will still do what? Contracts. Yes. Am I communicating? So if you just target only the size, only the level of the what? Mood like that, if you contract, you just produce one small that will be less than the weight. Am I communicating? You know, these things have the weight, each of them, each of the molds, each of the holes, they have the weight they can hold. Some maybe 1 gram, some maybe 4, 2 gram, depending. Now, when you now pour, overfill it so that as it's attracting, before you scrape off, it must set. So as it's retracting, the overfilled one will be filling the what? Space created by what? The contraction. So when this is done, if it says the one that will be on top is the one that's the excess one. You now do what? Scrape it off. Okay? You now scrape off that one. So that's what happens. So you do what? You overfill the molds. So when that is done, you now remove the what? Excess mass. So you cook for like 10 to what? 15 minutes. Then open the mold and do what? Get the what? Eject the what? Suppositories and do what? Package and do what? Store. Are we together? This is basically what happened. Remember, this one used for both large scale and what small scale production. But the one that is purely for large scale production, you talk about the automated what molding machine. Automated what molding machine. Generally, all the operations in this in the pour molding is done. It's same thing. It's the same process in the pour molding. The same process in what machine. But the only thing is that it's purely automated. Okay. The only difference is that it is what automated basically. So all the operations in pour molding are done by automatic what machine. It's now automatic in what automatic molding machine. So, and also the rate of production is what faster. Yes, very high rate, high, not faster. Yes, okay, it's okay. Very high rate of what production that it can produce up to 10,000 suppositories per hour. Is that not massive? Up to 10,000 suppositories per hour using automatic. This is just a general base because we will still go down to each of them. I told you there are two of them, right? Their production rate differ, the two of them. Okay, now, so the next thing I want you to understand here is that, of course, you don't need to be told that this one has a higher what production rate than the what hand molding. Now, also, a very important thing I want you to note there is that there is no chance of what air entrapment in this one. Where do we have much of air entrapment? There is no what chance of air entrapment and contamination here. Do you know? Can someone tell me the reason why you have no contamination? Yes. You know that one. The other ones, your hand are involved. Other things are true of us. Yeah, but this one, there's no chance of what contamination. Now, but there's an issue here. You should be careful with. That means the mold should be properly what cleaned immediately after what production. Okay, it should properly clean because if there's remains of whatever on it, they will do what stick there, and it's a problem. One, it will cause to producing overweight suppository because that may add to what good. Are we out together? And that thing that is left on the they will set now. Remember, when it's cool, they will set this. If you don't clean up immediately, they will set and be on that thing may create scratch or mark on the what suppository, which may not be a good thing. Am I competing? If you go to buy drug and look at the scratch on it, you feel somehow. Two of us, you will think, am I sure this is not fake? Even at that point, itself, the drug will not even work on you because you are always having issues psychologically. Two of us, good. So here now, the mass deposited on the food should be cleaned. Of course, there are tendency for some mass to be what deposited. So clean them immediately to avoid leading to what overweight suppository or even causing scratch on the what suppository after the molding, after the production, because it will leave an indentation on it. True of us, yes, it will leave an indentation on it. Maybe if the shape of the scratch is like star, for example. Now that means after the suppository that will come out of that mold, you will have an indentation on that have star shape. True of us, I don't think it's good. It's not a good thing. It will have issue. It will mess the aesthetic value up. Two of us, good. And I don't think you buy it if you see it. In fact, you tell them to change it. Even if you don't know what it is, you say, please change this in for me. I need the one without star on it. Two of us. Now, the next thing I want to talk about is let's now go into these two types. Okay, into these two types of what automatic molding what machine. Now the first one I want us to look at is what the rotary machine. From the term rotary, it's clear now. It rotates, right? Good. Rotary machine. So that 10,000 I told you just an average for all the what But when rotary machine specifically, this one has about 3,500 to produces about 3,500 to 6,000 suppository per hour. Please know the difference. This one produces about what? 3,500 to what? 6,000 suppositories per hour. Now, from the name rotary, it has a turntable. You know what a turntable is? Where you have something that turns around, okay, rotate like this, turntable. As you can see it, look at it in the next page. Can you see it? Can you see it? Can you see it? Next page on the course material. Can you see it? Good. That's what you call what? This is what the rotary machine is all about. It rotates. Is a turntable that rotates like this. Okay. Good. Okay. So yeah. All right. So I said that this machine consists of a what? Turntable in which metal molds are fitted. So the metal molds are fitted on this what? In this what? Turntable. So it rotates sequentially. It rotates sequentially. So the molds will get filled with the drug. As rotating, when you get to a particular station, when it came to a station where the mold and the will fill with what, both drugs and the additive, it will move again until you get to a place where it will do what? It will get cold and do what? Eject the what? Suppository. Eject the what? But before filling, look at it. Can you see? Can you see? Look at let's go to that the diagram. I think it will help you to understand it better. Look at it. Let's look at the diagram. Can you see it? Now, if you look at it, that should be figure 19.4. If you look at it now, you see that place, the part labeled 1 is what? Is what? Feeding the device and filling hopper. This is where you feed with the ingredients, okay? Where you feed it with the what? The ingredient. Now, number 2 is what? The one I you know that this feeding device is fitted on that, right? Good. Then number 3 is what? So after the setting and cooling, it will be this where it is ejected. Can you see suppository being ejected from there? Yeah? Number 4 is what? Remember what I said? What I said about what? Scraping, right? The excess mass, right? You scrape. Good. So this is where it is scraped. Now, the next one is the 5th one. What happened in the 5th part? What does it do? To cool, right? To bring down the temperature, right? Are we together? Are we together? So this is the functional parts. Of course, this is a schematic diagram that shows the main part. This is not how it looks like in real life, okay? It's just a schematic representation to show you the functional part, to illustrate the functional part. This is exactly what happens in what? You have how many stations do you have there? How many? 5, right? What are they? Station Is it 5 or 4? No, turntable is there on its own. I mean the station where things happen. First one is what? The filling, right? Or filling station. The second one is what? Ejection station, right? The third one is what? Scraping, where you have the scraping device, right? And what? Cooling station, where you cool, right? So this is basically what happens in what? What happens here in what? The rotary what? Machine. Are we together? Are we together? So I said that the turntables rotate sequentially. Then the mold gets filled with what? The drug. The empty mold, it filled with the drug, the additives, the bases, and is cooled and eject the suppository at each of the respective stations. But note, before you fill the mold with the mass, note please, ensure you apply the what? Lubricant. Please apply what? Lubricant. Of course, you know that the excess mass is scraped at where? The excess mass is scraped at where? No, say it. Yes, say it. I've said it, but say it. As scraped at where? I keep saying it. Sometimes, sometimes applying rote method is it works. So, okay, you know what rote method of teaching is? You did your catechism, right? As a Christian, you know the catechism. Wow. They will carry the whatever document they are using. They say it. You repeat it after them. Three of us. That's rote learning. We call it what? Rote learning. It helps. So sometimes I like combining the two of them. I'll ask, even though you have said it, by the time you say it again, and again, it does what? It sinks. Okay. So if I ask, answer. Don't say we have said it. All right. So let's go. So the excess mass is removed by what? At the what? Scraping what? Units. Now, of course, even though we talked about the cooling system. So the cooling system now does what? Solidifies, right? It helps to do what? Bring down the temperature, then it do what? Solidify. True of us. Remember, in that molten state, it's at higher what? Temperature, right? It will cool it, bring it down, then it does what? Solidifies. So the cooling system results in the what? Solidification of what? Suppositories. So after the cooling, listen carefully, after the cooling, the mold is moved to where? The ejection what? Station. All together. So this ejection station is just what? Consists of what? Stainless steel rod that pushes the suppository from the what? Molds. So what eject actually does the ejection? What actually does the ejection is what? The stainless steel rod, right? That does what? Pushes the what? The suppository out from the what? The mold. So when this is completed, the empty mold is what? Move towards the what? Filling unit. Remember, the empty mold enter the what? Filling units, and all this process took place. You fill it, it gets to where? It gets to where it cool. After cooling, ejection. After scraping, cooling, ejection. It will still go back and continue again from the where? From the where? Filling station. That's why it's a turn. It goes like this. Okay? It goes like this. It works like a turn. It's a turntable actually. Now another one we want to look at, as you can see, it's just the same process. Remember I said that the same process in the pour molding, because heat is also applied. True of us. But the point there is that it's now done by what? Machine. Remember in that one, first of all, you first of all by yourself. Remember, in pour molding by yourself, you do what? You mix the what? You melt the base, right? True of us. Then you mix the what? Dry and additive, right? Then in what is it called? In warm water, you do what? You titrate. Then after you divide into two. First of all, the first half you mix with the base, mix properly then before you add the second, before you now continue. But this one now, you are just pouring everything in the what? Filling station, okay? Remember what I told you? I think I gave you instance, an example of automated garlic processing company I saw online. Up to today, I have not seen that video again. I basically did not know the company. And just get your cassava the way it is. Pour it, everything, pour and go and rest. It will wash, it will clear. Just go and wait for it at the end. And carry your bag of garri and go. Because you put everything each station needs and go, just carry your bag of garri. Your duty just to be time it. When the time comes, get there, be packing your garri and be packing. Simple. What did I say? Carry your garri. You're not even the one to carry itself. Okay, so this is exactly what happens here. Just pour everything on the hopper, and everything will happen turn by turn from one station to another what? Station. That's the power of what? Automatic machines. It makes it easier. Okay, now let's look at linear machine. Linear machine is just the same thing. It's the same number of stations, the same thing. The only difference is that the rate of production is what? Higher. Okay? That is the only thing, the only difference. So it is similar to what? Rotary machine. But what happens is that this one is linear, unlike the rotary machine, and the rate of production is about what? 10,000 suppository per hour. So all the steps involved here are similar to the one in what? Rotary machine. And there is also no room for what? Air entrapment and contamination. So the same thing with what? Similar with what? Rotary machine. Are we together? So this is basically what happens here. So another point I want to make is that in as much as this one is better, run away from anything what? Water, okay? Because on a normal, the reaction of the ingredient are more likely to occur in what? Presence of what? Water. You know, water is a medium for a lot of reactions. Hope you know. Are you aware? Are you aware? Water is a very important medium for a lot of reactions. So there's tendency for the ingredient to react if there's what? Presence of what? Water. Another point I want to make is that please, incorporation of water or other substances that might contaminate with bacteria or fungi necessitate the addition of what? Bacteriostatic agent. You know, preservatives. Sometimes, depending on what you want to add anyway, depending on what you want to incorporate, if you want to incorporate water or any substances that has issues with what? Bacterial contamination, please, there's always good to do what? Add what? Preservatives. Example is parabens, okay? Paraben is an example, and it's what? Bacteriostatic. You've done bacteriology, right? When an agent is bacteriostatic, what does it mean? It does what? When an agent is bacteriostatic, what does it mean? Okay, when it is bactericidal, what does it mean? Were you taught this? No. Okay, maybe you are 211. I think you, okay, sorry, what are you doing now? Just general microbiology, right? Introduction, right? Okay, you are 211 now, you now narrow it to drugs. You now narrow it to, so what you are doing now is just for you to know about these microorganisms, okay? So when you come up, but I think, so some of you asked me questions, so some of you came to me asking questions about how morphology, the relationship with drugs, right? I think, okay, maybe that question was there to prepare your mind. Actually, when it's bactericidal, those agents, antibacterial that kills the bacteria, they kill bacteria. But this one, they will slow down a lot of things in the bacteria, maybe some metabolic process in the bacteria. They will slow down they don't clean them, they will slow down their growth by affecting some metabolic pathways in them to slow it down, not actually clean them. Things like penicillin, amoxicillin, campicillin that attack the bacterial cell wall, they kill. Because when is the cell wall that contains, sorry, this is not MCB class. Let's continue. Let's continue before I go into another thing. So now, so just like as we met in tablet, right? As we met when we discussed tablet, so basically also has its own what? Has its own what? Issues, problems in formulating it. Has its own problems in what? Formulating it. So in our next class, we'll continue from where? From here, okay? In our next class, we'll continue from here. In the next class, we continue from issues, problems with what? Encountered in suppository words, formulation, and how to take care of them. Any question? Any question? Any question? Okay, in the absence of questions, we'll stop here. See you. Today is what? Monday. Okay, I was about to say see you on Monday. Sorry. See you tomorrow. I thought today is Friday, sir. See. You have what? Who is tomorrow? What's that? Okay. I forgot. I forgot. I thought today is Friday, so I forgot. A lot in my mind. Okay, okay. Today is Monday, right? Yes, and we should have quiz today, right? Good. So my saying no. You don't want to write quiz again. The 13 quizzes must be completed. Are you quarreling? Are you quarreling? Take it easy now. We're coming down, auntie. To take it easy now. She don't like hearing that word, that statement. Will complete. And you must be complete actually. You must be completed actually. So being angry will not help issues. All right. So I don't know what this power is. The power is messing me up. But let's see what they can do. But we have class by one, right? Right? Good. Is it by two? Yes. Okay, we have class by two. Sorry, I was saying tomorrow. We'll continue by two. Sorry, not by one. Not tomorrow, by two. So whether it will just please, your studies should not depend on whether quiz is holding or not. Okay? Study. Am I completing? Please study. Study. It has no business with whether you're writing quiz. You're not here to write quiz. We are here to do what? Learn. That's why you are here. So study. Whether we're writing quiz or not writing quiz is inconsequential. Do what? Study. Don't allow, in fact, what's that? Ask. Aesthetic. Now, as in elegant appearance. See how beautiful you look. Aesthetic. You are new hair, you attractive, inviting. You know, if you look at it in English, if you look at it, it's beautiful. All right, so please study. It cannot be met with whether you are writing quiz. I wonder how you do this thing, how you sleep. How do you do it? Sleep with your two eyes closed when something was taught in the class, you have not grabbed it. How do you do it? People are trying, Wait, how do you do it? After today's class, some things we are taught in class and you do not understand them. How do you sleep? People are trying, seriously. That's why if I see people run up and down because there's quiz, do you know? If I say people say it's not possible. If you tell me that I have quiz tomorrow, my rate of study will just go down. I won't even want to study again. You see me carrying something like that is not even do that thing. To do that thing, I'll just get tired of it. Tell me that question. When I study is before that lecture or immediately after that lecture. A particular thing. If I want to study because I want to write quiz, I will not study. I will be distracted. I will not be here. So, and that thing, anything I could not study before the semester, or I could not study it after that lecture, that exam I'll have issue in it. Or the most seriously, gives apart. You know, people differ. If one or the other made me not to study, finish that outline before the semester begins, or study it before the lecture or immediately after the lecture, and if it made me to, maybe out of laziness, I did not study it before the exam. If I take the exam, I don't want to read that thing again. I'll get tired of it. Just so that I will not have the score I'm supposed to have in that course. I have accepted it since throughout my days in school. So that's why when others are going for break, I will go and start looking for what we are going to do in the next semester. Or if I couldn't get everything, Before I say I want to go and sleep, you see me, I'll be free sleeping, I'll walk around with it like this to make sure I go through it before sleeping. That's why if I see some of you after class, nothing is in your head, you go to hostel and come back again, empty head. I wonder how you do it. Because in the class now, questions must be asked in the class now. Hello? I got a question in the class now. I got the question. Not for you, me got the question as my lecturer. If you're going to a class and I am in, you just be prepared because question must be asked. Because it's through that question I'm asking that makes me to do what? Understand it better and retain it. Try it, it works. Study before that lecture. It works. It works. Means I really like students that ask me questions. Because if you ask me questions, I will go back and study. I will see how empty I am. Then I will go and do what? Study. Because me, I want to study too. Hello? But if I just come and just be pouring, after pouring, I will go empty-handed. You are cheating me. So I want you to study ahead, prepare yourself. Then bring up questions, look at it. Anyone I don't know, we postpone it. Next day we do what? That's how I want my class to be. Not people that will sit down and looking at me like this. I think only few people engage me in this class. Only few people engage me in this class, and I'm not comfortable with it. I will say any question, you say no question. Any question, no question. How is it possible? But when you write quiz, you don't get 20 by 20. If you say no question, that means all of you should score what? That's the meaning now. The third person is saying no question. We're giving you one nonsense score. It's not encouraging at all. Please, those apart, prepare ahead. Try, very important, try. It's not easy, but try it. You can say, okay, before coming to, I have 152 today. I have, the courses you have for the day. You can bring out 1 hour, 2 hours before that day. Look at the topics you want to do, the next topic they want to teach. Like me, now you already have my material. You look at the next topic I will teach. Even if it's only that, even if it is 3-4 page leaves of the material you go through, or 10 slides, go through, pick points from there, do more research, prepare questions where you're confused. Then you prepare yourself and come to class. You see, as I'm teaching, you are following. And you will not be distracted. Because you are trying to hear my own version, you are trying to get my own understanding of that thing you have read. You see, you won't allow yourself to be distracted. You want to see how, because as you are reading that thing, you are reasoning that thing on your own, right? Then when you now come to class, you want to find out my own idea on that particular, and you see, when I now explain it, if you come to a place where my own understanding aligns with your own, you to know where you do like this. Because it's entering. Then you areas where you not grab, you ask questions, three of us. But if you don't have anything inside you, what question are you going to ask? You are even struggling to understand. Maybe some words I'm using, are even confusing yourself. You need to know where to start from. That's why at the end you see yourself struggling to catch up. I'm giving you clues on how to study. You see yourself struggling to do what? Catch up. Exam no go I see quiz quiz. A class. Why are you sleeping in class? Because you want to write quiz. Nonsense. It doesn't make sense. A day before quiz, you go and sleep well. before your exam, that night you should sleep well. Hello? That night before your exam, you should do what? Sleep well. You see, if you're answering question, you are coordinated. Forget what exam you write. Eh? You said you need to think. Not that one they just be asking the direct question. Those things you cram, you pour. No. If you go to the real exam where you will need to think, you see that if you don't sleep well, you will not be able to think to answer that question. Because you see the one least you have crammed that one. Least is maybe you be given area of concentration. You cram it, you come and pour, you cram it. Then after pouring it, one nature. If I call you to ask that thing, you will not be able to say anything there. Do you know why? It did not enter. Obanalo. Or just hang there somewhere where you pour it and go your way. So please let us, re-examine our study, the way we study. The time to study well is when the beginning of the semester and when the lecture is when it is heated. During that time, if I must do anything with you, or if I must study again a day before the exam or night over, I will just sit down and be discussing questions, just answering questions, just question challenge, just answering questions, not to sit down and start looking for. If you come here, see some of you, hold up and down, you're cramming. You're just cramming. So let's know how to study, okay? It's very, very important. So see you in the afternoon. God bless you.